Hello, everyone. How's it going? Good.
Uh-huh.
Hopefully everyone can hear. Yeah, sorry to switch up the days on you all. We decided to switch to Thursdays. So take note, we are not going to be convening on Mondays at 2, but Thursdays at 2:30. So hopefully it's an okay switch up for you all. I'm excited because I feel like it. I don't know. Thursdays I feel like are just more fun. I don't know. So for anyone that is new to this awesome show, the Linear Tig regression, I'm Miranda All. I'm a developer advocate here at Timescale. And yeah, I'm really excited to be here and learning so much from our awesome engineer, David. You can introduce yourself too.
Hi, everyone. I'm David Kohn. I'm a software engineer here, and I'm actually taking on a new role as engineering education manager. We're still trying to figure out exactly what that means, but it means that I will have some more. I will definitely be doing this type of education work, both internally and externally. So, yeah, I think today we're going to continue some stuff from last week. I'm going to go over some of the stuff that we did last time in brief. And then hopefully move on to some new stuff. And so this is all with some caveats. This is all still a work in progress, and there's still the slides are a bit hard to develop on this. So this is a workshop. So we'd love feedback on sort of what's working, what's not, in terms of explaining some of this stuff. And there's still going to be some more work done as we build this into blog posts and other sorts of stuff. But a lot of this is going to focus on window functions. Maybe you can put the screen up now. Awesome. Yeah, so we're going to be focusing on window functions. As I said last time, they're sort of magical, but magic is sort of can also be sort of mysterious or supernatural. They're very powerful, but yeah, a little bit arcane. So there's a lot of places where all the information exists, and you have to look a lot of different places, like even in the Postgres documentation, there's a lot of different ways that they can be used. So some of this is also just some opinions about how we should be using them. Yeah, so what are window functions? We said, well, okay, we knew about aggregates from previous stuff where they take multiple rows and produce one result. We know about sort of normal functions that take inputs from one row and produce a result for that row. Window functions, and we had some examples of those. So we had greatest and max, right? And a window function is similar, like has qualities of both. So it takes inputs from multiple rows, but still produces outputs for each row. So the window function, when we're doing the max, can do the max over all the rows as input. And so, but you see there that it's, so even though it's taking all the rows as input, it's producing output for each row. And we talked about empty windows. We talked about different ways that you could use them and sort of see how they begin to get significantly more powerful. So then we talked about whether they were actually just aggregates. And we talked about some best practices, so syntax and best practices. So first we learned about the over clause, so empty window functions. We talked about named windows and how we should name them descriptively and not use like what a lot of the docs use, which is just W, which doesn't tell us anything about what the window actually is. It's much nicer to actually name them something useful. We learned about partition by, which is sort of like a group by clause in an aggregate, but instead it sort of breaks up the set of rows into different subsets over or partitions, right? So that limits the area that you can see in terms of the number of rows or in terms of the type of rows. So in this case, we were partitioning by symbol. And now we're getting to some of the new stuff that we sort of covered in some of the sort of freeform stuff afterwards, where we're just going into the SQL. I have some new slides here. And then today we'll also probably have some more SQL freeform time. So if you have questions and stuff like that, we can definitely go over that as we get there. If you have any questions while I'm in here, please do put them in the chat, and we'll try to answer them. When we use an order by clause in our window definition, we can get a cumulative result. So as we are ordering, in this case, we're ordering by time, price, and volume. And the reason that we did it by multiple things was to prevent ties. And at some point, I haven't developed this yet, but ties are a whole other topic for window functions. And they're a little bit painful to deal with, but yeah, so that's for later. But so we ordered by a number of things in order to prevent ties here. And you can see that we're getting now a cumulative sum of volume, sort of increasing in every row. Okay, so we get a cumulative result. So what does the internals for this look like? And I changed the names, but whatever. We sort of have a direction that we've ordered our rows in. And as we scan over, we see, okay, for this cumulative result, we're scanning over in the order direction or in the scan direction. And we get a result for row 1. Okay, cool. And then for row 2, we're now taking results from the previous 2 rows. And for row 3, we're taking results from the previous 3 rows, right? So we're just adding in as we go over, as we scan these rows, we're sort of adding in a new result each time. So what does that look like actually internally? So let's go back and review again aggregation. So when we think about aggregates, what's really happening is aggregates are still being processed row by row. So as we sort of process a row, we update a transition state. So for average, right, the transition state is storing the sum of the count. So we update that transition state as we process each row. The transition state gets updated. And then at the end, we can apply a final function and produce a result. Okay, so that's just a quick refresher on how aggregates work. Miranda, maybe you can link to the blog post and or some of our previous discussions, because we definitely went over all this stuff multiple times. So that is how just a normal aggregate works. So that final function is being applied to the transition state. So for a window function where we just have an order by and we're doing some cumulative aggregates, we can do something like this. Okay, we apply the transitions. We apply the transition function and get a transition state. And now we just want to apply the final function there. Okay, great. So for each row, now we're just applying the final function to the current transition state. And then as another row goes through, the transition state gets updated, and we apply the final function again, right? And we get another result. And as another row goes through and we apply the transition function again, we can produce our final result. And that's going to be the same thing that we got when we did this over the whole thing, but when we get to that last row. So that's sort of how this this internally works. One caveat here is that, well, 2 caveats actually. So you could imagine that if we didn't have this split between transition function and final function, that we might have to go back and just recalculate the whole aggregate for each row. Now that would be horribly inefficient, right? We'd be doing a lot of extra work in many cases. But if we were calculating the average directly, if we didn't have this idea of the transition state and then a final function, we would just have to do that. Okay, so that's one thing just to note. The other thing to note is that the final function can't modify the transition state if this is going to work, or at least it can't modify it in some way that's going to break it. So the final function here has to be marked read-only for the transition state, so that in order for Postgres to know this, it has to know, hey, you know, my final function isn't going to screw this up, because if the final function screws it up, then I have to go back and recalculate. Cool? Okay. So basic just on cumulative stuff. We're going to use our transition function. We're going to use our final function. Things work nicely. That's pretty cool. Okay, so then let's move on. Now let's talk about ranges. And we talked a little bit about this last time as well, when we were going over it in SQL land, but let's do something a little bit more. Let's get into the internals again. So here we have, we're going to use a frame clause. So that's what this is called. So you can think of partitions and saying like, okay, we are saying that we are essentially grouping all of our stuff so we can only see things that have the same symbol potentially within our window clause. And then the frame clause is going to say, okay, which rows can I actually see? It's going to further limit what rows I can see from my current row. Think of it sort of like the partition clause determines the yard, and then the frame clause is actually determining the size of the window that you can see out. So here we're partitioning by symbol, we're ordering by time. I don't know where the order fits in the yard analogy. It doesn't work very well, but whatever. The frame clause here now is we're going to use rows. So you can use range, rows, or groups. And at some point I'll have some slides on all of those. For now, the simplest one for me anyway is rows, because it just says, okay, I'm going to look at the rows on either side. Groups deals with ties. And once again, ties are friggin' weird. We have to talk about that sometime later. Luckily, I made an order by clause that doesn't have ties, so we're fine. If I had an order by clause with ties, then maybe this would be a little bit different, or be a little bit weird. Think about how to use those and for what types of analysis that makes sense when we start talking about groups, and we can talk about that later. So now what you see is that if I'm, so now what this rows clause that I'm using is between one preceding and one following. So in a rows clause, you just give it a number, has to be an integer of the number of rows before and after. You put that between if you want to go before and after. If you want just before, you can leave out the between. Or you can say between two preceding and current row. Right, so there are different ways of doing that. At some point, we'll also talk about frame exclusion clauses, which are also fun, but later.
That sounds thrilling.
This is one of those parts of syntax where it's very complicated because there's a lot of stuff that you can do with it. I haven't seen anywhere that does a great job, honestly, like any language, SQL or otherwise, that does a great job with this type of analysis and specifying it well. And so it's just one of those things that to an extent you have to put up with and recognize that, like, yeah, the syntax isn't perfect and it's a little bit hard to understand. It's going to take you a little bit of time to get your head around it. But once you figure it out, it is incredibly powerful. So, so I named my window here 3 rows by symbol, right? Because I'm partitioning by symbol and I'm ordering by my order by, right? I have a nice order by, and then I'm getting 1 row before, 1 row after, and then my current row is the 3rd row, right? So we're getting a 3-row sum here, 1 before, 1 after. Okay, so, and that was partially to set up my graphic because I didn't really want to have to draw this with 150 rows or with a range. That's a little harder. So range, by the way, we can go over sometime later, but especially with time series, range could be really useful because it can say, hey, I want 15 minutes before, 15 minutes after based on this row time, right? So I ordered by time, I can say I want 15 minutes before and after. Now, yeah, so we'll have to talk about exactly how that works. But especially if you have multiple, I don't actually know how do we do that. We'll have to look that up if we get to it. But like if you have multiple times that you're ordering by, I don't know which is used for the range. Good question, eh? We'll have to figure that out. And or how you specify that. There may be a way that you do that. I'm not 100% sure. So let's look at what sort of this is doing, right? So we know that this is sort of going through and each row is going to have a few rows attached to it. So as we scan over our rows, we've ordered them by time or whatever, like our whole ordering thing. And we see that, okay, the first 2 rows go into result 1. There isn't a 3rd because we don't have anything before it. So that's just one thing to note. Now,
and last time, right, we discussed like to be wary of, you know, any kind of sums or things that are taking into account rows that like won't exist for the first, you know, ever so many rows. So like in this case, the first result may not be super reliable because it's missing a third kind of piece to the puzzle.
Yeah, and we went over some ways to get around that, where you can expand your where clause and then do that in a subquery or in a CTE, and then select out once you know that it's started. So there are different ways that you can think about doing that. It sort of depends what you want to do. How you're going to do that, and we can talk more about that later. But with time ranges and stuff like that, it's a little bit easier. Anyway, so let's just look at how this works, sort of, again, the internals. So then as I go through my second row, right, I'm now taking results from the first, second, and third rows, and that's going to go into my second row. And then as I go to my third row, that's going to take rows from, take inputs from rows 2, 3, and 4, and then output my third result. So what does that look like internally again? So again, let's start off with our aggregate things. You see that we have our, we've changed our query here. We're going to order by time. We're going to have a rows clause between one preceding and one following. And as we go through, our transition state starts getting updated. Okay. The last time when we were doing cumulative, we output immediately after that first row. But here, we can't output our first row until we've seen our second row. So we need to see our second row. Now we can output. Right? And then we'll see our third row. And our third row, our second result took into account the rows from our first, second, and third rows. So after we see our third row, we output a result. Okay, but now what happens? We've reached the end of our frame for this second row. Our transition state, right? Our transition state has input from these 3 rows, but what we need is the input from those 3 rows in order to produce our third result. So we sort of have 2 options. Either we can recalculate starting from those 3, or we can figure out some way to remove that one and then add in the last one. And those are basically the 2 ways that Postgres allows you to do this. So, and the way that you determine that is with your create aggregate. If you provide these M functions here inside of a create aggregate, you'll see that there are 2 things. So M stands, I think, if I remember correctly, for moving. So this is the moving mode, moving aggregate mode, right? We're now using some sort of moving definition. We now have the same state transition function. So you can define a different state transition function because maybe you need to store some different results if you're doing it in moving mode. And we also have this special thing, and we have the same, everything is the same except, right? So we still have a final func, we still have the type, etc. But there's one thing that they've added, which is the inverse func. Right? The inverse M inverse func there is the thing that we use to remove that row. So, and this is where I reached the end of my slides, because this is as far as I got, because, you know, this is a complex topic and there's a lot of stuff to cover. And yeah, I haven't had time to do all. I was hoping to go back and do some more slides to explain some of this stuff and exactly how that worked, but it was the graphic design stuff was just taking too long. So we're just going to have to talk through it. So the inverse func is going to remove rows from our window, and then we're going to add in. There are a few things to know about that. And maybe I'll switch actually over to. So let me demonstrate a few of those things. So first off.
And just to kind of recap, those 2 options when creating an aggregate are the 2 ways that you can define how the window function will react whenever it needs to calculate windows. And so the 2 options being either remove data to calculate the next like chunk of rows, or recalculate by like looking at the rows, kind of maybe duplicating, looking at certain rows to make sure that the calculation for the transition function is right. Is that?
Yes, that's correct.
Cool.
Yeah. So, so there are a few things that, so there are basically two different ways that you could do it. You could either recalculate starting at the new, starting just over all of the rows in the window definition, or you could do it, let me actually go back to, I have this here. Because there actually is something, why, you just, oh my God, really? Sorry, I have multiple desktops and my, my little dock bar was just like, as I was going to it in one, it was popping to the other. And as I went back, anyway, it's like it's playing whack-a-mole with me. Okay, so
Max. Gotta love them.
So what we sort of said is we have input from these 3 rows and we want input from these 3 rows. So what we said is, well, we can either recalculate over these 3, or we can remove this one and add this one in. So let's talk for a minute here about why. So in this case that we're talking about, the difference is actually probably going to be small, right? Because there are only 3 rows. However, if I could have a million rows in here, right? I could have, if I do say range 15 minutes preceding and 15 minutes following, so now I'm getting a 30-minute rolling average. When I move to the next row, I could pop out a few rows and add in a few rows, and there might be a million rows in between. So recalculating over all those rows can be much more expensive than removing a few from the beginning and adding a few at the end. Now, why might I not want to do that? Anyone have a guess in the chat?
So this is the question of cases where you would not want to remove the data, but you would actually want to recalculate everything.
Yeah.
It's hard because that seems like recalculating seems like it would always be more computationally like expensive. So I don't know. Yeah, I'm struggling with coming up with an idea.
Okay, so let's think. So there are a few different things, because actually the internals are very interesting here. So let's think about a few simple aggregates, and then we'll talk about some other things. So here's the first simple example. Let's say I have max. What do I store as my input for max, or as my like transition state for max?
Oh, I see. Yes. Okay.
What do you see?
Okay, I'm following. So with max, right, you're looking at all the rows and you're recording the highest value that exists in the kind of the rows covered. But you're not storing which row is the maximum value. So if you remove rows, then you would still like there. I don't know. I'm guessing that you could run into like a. You'd have.
So let's think about what the max algorithm is doing, right? It's not It's not like it's after each row. It has some state. It says, here's my highest row that I've seen so far. I then when the next row comes in, I look at it and I say, is this bigger? Right? So if the answer is yes, then I store the new thing instead. Okay, cool. So that's my algorithm basically. And so now, yeah, but we don't know where that row was, so it could fall out. Okay, so there's a thing that we can do about that though, right? And there's a shortcut here.
Oh.
If I remove a row and it is equal to my max, that's the only time I need to recalculate. If I remove a row and it's less than my max,
right,
well, I'm fine, right? And I can keep going.
So kind of like another built-in check for when you drop off rows.
Exactly. So, and this is actually an interesting thing because Postgres built this idea into the way that it does this. So what it does is it allows you as the developer of these internal functions to return null. So if you return null from the inverse function, it says, oh, I have to recalculate. So let's think about what that does. It says if I'm doing max, and what I'm checking for is like, is the new thing bigger than my old thing? And then on the inverse function, what I'm checking for is this thing the same as my biggest thing? And if it is, then I return null. And I say recalculate, please. Otherwise, I'm fine, keep going.
Okay.
Right, and I can do that for multiple things, right? As long as we don't have...
Just to clarify, if it does contain, if the rows dropping off do contain the highest value, it sets it equal to null?
Yeah, so what it does is it returns from the function null, which tells Postgres, oh, I have to use this other strategy, right? I have to use this strategy now.
Okay.
Right? So, but if I'm removing this one with max, right? We're talking about max here, we're not talking about average. Right? Then I can do some of that. So that's the basic idea, right?
So I'm sorry, out of curiosity, so sorry.
Yeah,
out of curiosity, if we're talking about max here and the first row drops off, which one clearly is not the max number in the previous set, what does it return then for the inverse function, like other than null?
It doesn't, yeah, so sorry. Wait a minute, say that again.
Okay, so so just because this is all new to me too, folks.
Yeah.
So this is like me hearing this for the first time. So excuse me for asking questions. So okay.
You're more than excused.
Great. So
still confusing to me, and I've seen it multiple times now.
Yeah. Okay, so the inverse function is essentially this like extra check.
Mm-hmm.
Is that correct?
Well,
okay.
No, the inverse function is the function that removes this row.
Okay.
Right? That's why it's saying it's inverse. It's saying I'm going to take my state and I'm going to what I should tell you a couple things. So the inverse function gets as input. So if you think of the transition function, when we did that, like when we wrote it out in pseudocode, what it was basically saying is I have the current state and I have a new row and I produce the next state. The inverse transition function is saying I have the current state and I have an old row. I'm going to produce the state that would be there if that row had not been added. Right? I'm going to invert the operation that would be applied by the transition function of adding this row, or that had been applied by the transition function of adding this row. So essentially, you can think of it like this. It's let me do it this way.
So okay, while you type something, so the transition function, rows go in, state changes. The inverse function is that rows go in and it like inverses the function to remove the row that's not a part of the new windowed like chunk. Kind of.
Yes. And so, yeah, so what this does is inverse transition function says, the inverse transition function says I can get my current state back out. Like if I apply it this way, and I guess this would be current now. Right, so it just does the opposite. So it's basically an identity. It says current state equals or I don't know what we want to call it. Is inverse
Did you see this one question?
Yeah. Yes, exactly. So the inverse function would take, yeah. So in this case, right, like if we were talking about average, in theory, we would actually take this state, right, and we would decrease the sum by the value of bar, so decrease it by 1 in this case. If we were removing this row, it'd be by 2, and we would decrease the count by 1. And then we would add in this next row.
Got it. So the inverse transition function, or the inverse function, or whatever it's called, that applies to only the removing like option out of the two options, not the strict recalculating option, right?
Yeah, exactly.
Okay.
So
Got
yeah,
it.
the inverse function is only applied if we're doing this.
Got it.
Yeah.
And it also became clear to me too.
Yeah. And then we apply the normal S func, the normal transition func, or MS func in this case, so that we apply this thing instead. Like, and that's what we would use if we're calculating as well.
And so the trick, so you were saying with Postgres, it doesn't necessarily give you like the strict option that you have to choose one or the other, but it kind of integrates the two methods together.
And it's exactly for that reason that we were talking about with max, right? Because the max occurs relatively rarely. And so I might need to recalculate, but I don't need to do that all the time. I only need to do it when the row that I'm removing is equal to my current maximum.
Right.
Right? And so that means that I can avoid maybe 90% of the work or more in many cases. And it allows me to sort of switch tactics at runtime. That's the basic gist. I need to keep these rows around no matter what, right? I need to have some in-memory thing, so it's going to like materialize these rows somehow, or like put them in memory, or allow them to spill to disk, or in this case, it has a tuple store, is what it's called internally, and so that you can see which ones are falling off the back, so you can rescan over ones that are in between, right? So that all is going to happen no matter what. And we have these two strategies, and this allows me to sort of flip between those two strategies as I see fit inside of my algorithm.
That's pretty clutch that Postgres has that.
I agree.
Nice.
So, and this is, so we did a couple things here, right? Like, for instance, for StatsAct, so Postgres doesn't provide an inverse function for most of its statistical aggregations. Why is that? Well, because if you subtract with floating point arithmetic, which has, you're introducing error, right? Like, let's say I have 1.002, and then I add in, you know, I don't know, something like 10 to the 310th, right? Which is at the edge of where floating points can represent. Well, that 1.002 is going to fall off. Like, we're not going to get, that's going to be gone, because all we're going to get is 1.00000 times 10 to the 310th, and the one that's like way over the other end, it doesn't matter, right? But if I then subtract that 10 to the 310th out, then it's just going to be wrong, right? So that's just something like, so that's something about how floating point numbers work. Now, we did something that was a little bit tricky, where we said, okay, well, we don't want to have to recalculate this for everything. We're okay with like maybe a little bit of error as well, a little bit of extra floating point error. There's always some floating point error that you can have, right? But we said, well, we'll introduce a quick test, and we'll see if the value that we're removing is a significant chunk of the value, like in terms of total value, is like a significant part of the overall stuff that we have. Then, well, we're going to return null and let it recalculate. So that was our workaround for how we would like trade-off between floating point error and speed. That's a little bit of a different trade-off than what Postgres normally does, where they're like, we want the same result no matter what.
And this is for our
StatSag function.
Okay. Okay.
Yeah.
Yep. That's what I thought. Cool.
So we made like a slightly different choice there, using this internal thing as our like means to do it, where we were like, okay, we're going to check and see if it's big compared to the result.
And so is that kind of like why we have like the error options within a lot of our aggregates, is like because of some of these decisions that we made?
No. That's because those are sketches and they're always going to have some errors. So that's a different thing. This is like floating point error, which is a different thing, kind of. Okay. So the one thing that I will say is we need to add some notes to the StatSag, and we may also add in a version of StatSag that doesn't do this automatically. So
okay.
Like,
so kind of like giving the option to take a less efficient calculation, exactly. But so it's more accurate.
Always do this. Like we're going to add in an option for StatSag that says always do this second strategy, because I don't want any chance of there being even a little bit more error.
Okay. Mm-hmm.
Right. So we may add in that option at some point in the future. So that's, that's some of the stuff that we're doing and playing around with, and like really, yeah. So that's sort of some background.
Sorry, I got real in the weeds there because I was
no. I mean, this is exactly.
I wanted to understand.
No, that I think people like this. It seems like some people like this. Raj seems to think that it became more clear, which is great. So, David, I am not quite sure what your question is. Maybe you can clarify in the chat, and I can try to answer a little bit better. I can try to, yeah.
I'm guessing for that question from David, the downsampling time series data, can you fill backwards and forwards?
Are you talking about gap filling? Or
yeah,
are you talking
that's
about something else.
The impression that I'm getting, but maybe I'm reading it wrong.
So maybe you can clarify, David, and we'll try to get into that a little later. So for now, though, let's go in and talk a little bit more about some of the other stuff that we do. So right now we have last observation carried forward as a sort of gap filling option, David. And you know what? I'm going to say let's put this off and maybe ask you to direct this question over to Slack or a different place, just because it's a bit off topic for this video and I don't want to go too crazy off to the side right now. Oh, this is Attila's downsampling video yesterday. So yeah, let's do this a little bit later, and we can or maybe ask even in the comments on that video, and someone will try to reply in a comment, or maybe in a future session of Attila's thing, he can answer that question. I just don't want to get too crazily off topic and do a lot of context switching, if that's okay. Thanks, David. So let's talk a little bit about some of the stuff that we do around this, because the next thing that I would want to get into, and where I think it's really cool, are tumbling windows. So we talked a bit about like how this works, and what you'll notice, by the way, as usual, I can't call up. So when we talked about this, right, you'll notice that Postgres provides an inverse transition function, but it doesn't provide an inverse combine function. Now, why is that? Well, its idea of how combine function works is only for parallel aggregation. So we talked about combine functions, that was like very much about parallel aggregates.
Do we want to recap on combine functions?
Probably.
Just as like a quick reminder, that might be helpful.
Find it. Let me find it.
Yeah, if you're interested in learning more, while David pulls extra stuff up, if you're interested in learning more about like transition functions and like the final functions and combined functions, we have lots of cool, or actually David wrote a great post kind of explaining how these different types of functions work, and how we integrated them in our hyperfunctions. Looks like
So,
you found this stuff.
Yeah, so let's talk a little bit about this. So when we talked about this was from the aggregate talk before. I've also just recently given it, and I think there's a couple of videos that should be showing up. So when we talked about aggregates, we also talked about this combine function, right? Sorry, so even let's go back. So we talked about basically saying, okay, well, we would parallelize our aggregation, right? Which would mean that what we would do is sort of calculate a transition state in 2 instances. And then once we got to the end, we needed something to do to combine our partial states together, right? And we said that that was going to be called this combine function, right? Which combines 2 partial states to produce something that then the final function can work on. And so that was sort of, this was how we represented that. So we said, okay, we're going to take things from different workers. And so this is how Postgres thinks about like combined functions. It doesn't think about them in the window context because it doesn't really assume that it's going to work there. And then we talked about we talked a bit about the 2-step aggregate idea. And what we did there was we said, okay, we have these combine and transition and final functions, and we're going to sort of expose that more to the user. And we provided this roll-up function that acts like the combine function. And Raj, I'm about to get to your question here. So one of the reasons that we did this was to allow for things like tumbling windows in continuous aggregates. So window functions don't work in continuous aggregates, but aggregates do. And you can then run window functions over the aggregates themselves if you have something like rollup. Now, it's not going to be right. So one of the reasons that window functions don't work in continuous aggregates is because what you're actually doing is you're producing a result per row. So you're not actually downsampling. You have to store all of the rows. And yes, they do a fair amount of work. So in terms of caching work, maybe there's a reason to have that. But in terms of caching results and downsampling, there isn't much of a reason. So that's part of why we didn't include them in continuous aggregates. It's also because invalidation gets weird. So, and because window functions are really freaking complex. So there's lots of reasons, but you can run window functions now, especially with our hyperfunctions like statsag over continuous aggregate results. So let's look at what that might look like. So right now, when we produce a result like this, so let's say we want like a 15-minute rolling average or something like that. Let's just do that over our raw data for this. And in fact, we have some of this stuff.
Sorry, my floors are creaky.
It's all good. So let's just do something like this, and we're going to do rolling. Let's say just, yeah, rolling 30 min. And we're partitioning by symbol. We're ordering by time ascending, and we're doing range between. Now we're not going to do current row and 30 minutes following. Let's do 15 minutes before and 15 minutes after. Preceding and 15 min follow. Okay, so that's giving us the 15 minutes on either side of our row as our rolling average. And we're going to just say select star from windows.
Do you have an extra parenthesis in there?
No, I don't, because it was a CTE. Hold on a second.
Oh, okay. Got it.
Okay, and I'm going to remove.
That makes more sense.
Okay, so what we're going to do is we're going to show you a couple things. So let's do max time, and we'll do this. Yeah, sure, we'll do max time just to show you max time over rolling 30 min. Max time. We'll do min time 30 min time, and we'll do some. So this is my sum of my volume. We could also do. So that's one way of doing it. But let's do two things here. So let's do the average volume using statsag. And actually, sorry, that needs to be average.
That's the.
And this is
Postgres average, or
no,
this is our average.
Yeah, because it's being applied to the statsag. You'll see that the statsag is here. And this is not total. This is HF. Okay, so something like that, and then we can just do av. Or we might have average price. Whatever you want to do.
Also, there's a comma missing after min time.
Thank you.
Yeah.
And we're just going to change this to be PG. Maybe we'll call this instead of HF, which confuses me because it seems like hydrofluoric acid. This is what happens when you employ a chemist in a previous life. Okay, so
sorry, real quick question.
Yeah.
You have average statsag of volume over rolling 30 min. The over rolling 30 min is inside of the average?
So the average, no, in this case, the statsag is going over rolling 30 minutes, right? And the average is being applied to all of it.
Got it.
So the statsag is the aggregate that we are now using as a window function. So we're using this aggregate as a windowed aggregate, a moving aggregate in moving aggregate mode, right? The same way that we're doing average volume, right? And you'll see, by the way, that these match pretty nicely.
Okay.
It's still running. However, after a minute, because we have like 250,000 rows or more, and we have to rerun the aggregate because this is a floating point number. And so that thing that I was talking about our shortcut, gets used for our stuff, but does not get used for Postgres' stuff. And you'll also see that there's some ties here, right? So they're not. I didn't do the thing where in fact I could redo that so that then you're really going to get really slow. So anyway, this will take a few minutes to run. If I comment this out and cancel this somehow, how do I cancel in this thing? Connection, cancel current query.
Now I just feel like it's the never-ending query. Anyone? Never-ending story? No. Okay, just me.
Okay, let's see how long this takes. I haven't run this. I should probably do that, but so it's gonna. I think it's gonna run a bit faster here. Now it's gonna still gonna take a little bit of time because we still have 250,000 things, right? Or whatever, or maybe more. I don't know.
We couldn't. Did you see this last question that was asked?
No.
Okay.
For me, I use StatSag basics and query the real-time roll-ups and lots of awesome. Yes, that's exactly what they are meant for, Raj. So he says he used StatSag as like the basics in real-time aggregates, and then I query the real-time aggregates with roll-ups and lots of awesome hyperfunctions to provide an OLAP API, right? That is exactly what those were meant to do, right? That's why we provide StatSag and all these other things, is to do that. So great. That's exactly what we want.
We'd give you a gold star if we had one. Gold star.
Yeah, so this is still taking a while. I think it would probably take more time if you had the other thing, but who knows? Maybe anyway, it doesn't matter. The min and max may also be futzing with it. They may not be working right. And there may just be more rows than I think. There's lots of stuff. Let me open up a thing. It may also be that my client is beginning to fall over. Okay, so it's done after 93 seconds. We can run the old one in another window just to see if that would take longer.
Definitely was faster because it actually ended.
Yeah, but we'll see.
Guess we'll see how.
Yeah, we can see how long that was. And then I'm just going to do one other thing, which is I'm going to try running this without these two and see if that changes anything, because the min and max, they may not do all of the things that I think they do in terms of evaluating min and max with these windows. So let's see if that's any different. That does seem a lot faster, eh? Okay, so 5.4.
Nice.
Turns out they don't do the thing that I thought they did with min and max, which is annoying. Maybe we should provide some that do that. Right.
New functionality.
Yeah. So that's the sort of stuff where the or maybe that's something we can also contribute back to Postgres proper, right? So if you can get the part where you're doing sort of the moving aggregate mode to work right, it really can speed up queries. Now, what speeds them up even more is to do a tumbling window, like I was talking about, because really I don't want 282,000 rows here. What I want is like something every minute or something like that. So I'm going to apply a time bucket first. I'm going to then do roll-ups or whatever I want, and still be able to get standard deviation and all the other bits. So let's look at how that might work. And then I think we're probably going to hit time.
Yeah. And also, I will be posting these commands in like with the YouTube video. So for folks that maybe want to replicate or look more in depth at this code, I'll also be posting a copy. So just thought I would let you know. And also to David's, don't delete it.
Let me just pull this and copy it. Very good. Okay. So I was just about to do this. So let me just pull this out, right? Okay. So, and now what I'm going to do is, instead of doing this, I'm not going to do the over. I'm going to do the StatSag, and we're going to do it as a minute. So I'm going to do just a time bucket, and then we're going to do StatSag volume, maybe StatSag price, right? Maybe we want both of those. Or we could even do StatSag with a multivariable thing if we wanted to. Let's do that. That'll be fun. See you, Raj. Thanks for stopping by. If you can watch the end, it'll be up online. So let's do a multivariate StatSag on volume and price, just because we're feeling fun. So volume is Y and price is X, because that's how this works. And we'll call that, and we'll do time bucket. We'll do it 1 minute. Oh my God, what are you doing, Yeah. Time bucket. And we're not going to call this windows. We're going to say this is ags. Okay, so let's first look at what this would look like. I'm going to remove this third. Okay, so let's do that.
Do you need a comma after bucket?
Yep.
Bucket.
Thank you.
Yep.
Do it live. Okay, so now let's do a Windows. So we're going to rebuild our Windows as select. Well, what do we want? Well, we want maybe, so price in this case is going to be X and volume is going to be Y. Let me put that in a column here.
Also, the first CTE, the ags, that's kind of like, I mean, that's equivalent to what you might have in a continuous aggregate, right?
Yes. So this is exactly what you could put into a continuous aggregate. This could be our minutely continuous aggregate, and I was going to show you that you can do that. But let's do this first, and
sorry.
Yeah, so we'll do that in 1 second. So then we do Windows, right? So rolling this. So let's just look at our window clause for 1 second. So oh, and we need to and we still need symbol here, and we need a group by in this thing. So hold on 1 second. Time bucket, and we want symbol, right?
Because we want to use that in our window.
Yeah, right. And also like it makes more sense to group by symbol too. So we have a where, our group by comes after where. We'll just say group by 1, 2. And then put our thing. Oh, where did that? That shouldn't be there. Great. Okay, so now we're going to do Windows, and we're going to look at this, and now we still want to partition by symbol, and we're going to order by bucket. And we're still going to do our 50 minutes preceding and following. And then we are going to say, well, we want bucket, symbol, and we can do, we provide a rolling clause, which is like rollup, except it provides our inverse combine functions, essentially. And we're going to see the stats ag, so we're going to do stats ag. And let's name this actually as okay, so we'll do rolling minutely stats. And that's going to be over our window. Okay. And then we can apply our, so there are 2 different ways. So that's going to be our window. And now we're going to say select star, maybe, or we could just say bucket, symbol. And then we can just apply, and so let's name this. So this is going to be as rolling, or let's say tumbling stats. So now we can say, let's do average, and we'll do average X of tumbling stats. And sorry, I forgot a from clause. Let me do that. From ags is what we named this, right?
So the average X, why not just use average?
So we did a 2-dimensional stats ag on volume and price. So if we want price, then we use average X.
Got it. Okay. Missed that.
So let's put that in the name as rolling or tumbling price, tumbling average, right? And average Y, tumbling stats, as volume tumbling average. From Windows. Okay, so that now this is going to give us our tumbling windows. right? And this is also demonstrating some of the ways that you can use statsag to do multiple columns if you wanted to, right?
Right.
You can also get things like correlation or the slope, right? So if I wanted core as PV tumbling correlation, right? I can get a tumbling window correlation. That's pretty cool.
That is cool.
So let's run that. 312 milliseconds. That's not bad.
That was speedy. Wow.
Yeah. So, right. So why? Well, now we only have 422 rows instead of 250,000. Right. It's certainly a lot easier to do those calculations, right? And even if we used average or something else, like, but there aren't really ways to get some of these things in the real tumbling window sense with normal Postgres things. So that's part of why we developed statsag is to do that and to provide this type of thing. Now, this will still be, so like sometimes you don't even need a continuous aggregate. Now, if you want to downsample from 250,000 to 420 rows, like maybe that's a good idea still. Right. So that's the sort of stuff that starts getting really interesting with these types of results, in my mind anyway. And really just a really nice way to use these functions. And I think there's a lot of stuff that people can learn from here to just understand what's going on. So, and we see that we have like a tumbling correlation that, you know, price and volume are correlated sometimes and sometimes not. And maybe there isn't actually anything there. And, you know, I would need to be a data scientist to actually know what the hell that means, really. And, you know, Miranda, maybe you could explain in a future episode what that actually is saying, because I'm not 100% sure if even evaluating correlation over a tumbling window is interesting. Maybe it is, maybe it's not. So, but it still can be a good way to get even just the individual X and Y, right? The one-dimensional statsags, and like if you think you might want to do some plotting or other sorts of stuff. So that's the basic gist, just the beginning, I'd say, over this. There's a lot of other stuff that we can talk about. I mean, one of the ways that I would love to see more people using this stuff is to do like tumbling window stuff from your continuous aggregate and then evaluate that against a or roll up or rolled up windows, right? Evaluating that against current results to do alerting, right? So I don't want to take the raw current results and evaluate that back against my continuous aggregate.
Interesting.
Right? Like I might want a monthly tumbling window or whatever else, right? Maybe it's not even a window function, maybe it's just using rollup. But for baselining, I'm going to use my continuous aggregate because it doesn't need to include literally everything. Or it doesn't need to be perfectly accurate if I'm like 5 minutes off on either side. Like I've downsampled enough that it's so much faster to do. Right. So that's the sort of stuff that we can think about doing, and that get really, really interesting with this type of stuff. So yeah, there's
Which
just
is
a lot
pretty
of
exciting because like there's still, I mean, I feel like between these first two sessions, at least for me, I don't know, hopefully this is true for listeners as well. Like I feel like I've learned so much. So it's exciting that this is like still just scratching the surface.
Yeah.
It's awesome.
And yeah, so that's the like I think there's a lot of stuff here. It's part of why some of this stuff is just taking a while, is that there's just so much stuff that figuring out how to organize it and present it in a way that is really useful to you guys out there is hard. So please do give us feedback. Let us know if you know what else you want covered on this sort of stuff. And yeah, I think there's a lot of really cool stuff that people can do here, and a lot of stuff to learn. I like providing a little bit of the inside sort of internals view. You understand a little bit of what's going on, but it's also, you know, I mean, it's not necessary to understand it, I would say, but I think that it's, for me at least, it's easier to understand when I understand a little bit of what's going on, even if it's not perfect. It helps me understand what's going on. So I don't need to know how all of these inverse function works. I don't need to know all that stuff, but knowing that, okay, I can conceive of this thing as, oh, there's an inverse function that does the right thing for removing a row, right? I don't need to know exactly how it does that. And I'm not going to go into the math of how it does that in all the different cases. Like, that's too much. But knowing that there's a thing that does that and having a few example cases might be useful. So,
and I feel like it's cool to understand why some things are faster than others. I mean, we even saw like with these two queries, the difference that, you know, this inverse transition function can possibly play into speed.
Yeah. So by the way,
it's cool.
Yeah, I mean, if we, this was taking something like 140 or 90-ish seconds with the average versus like the normal Postgres average versus like 5 seconds with the stats ag1 because of that way that we're using that rolling window and accepting maybe a little more floating point error in certain edge cases. So, you know, but understanding that there are some trade-offs there, right? That you may be trading off speed versus like a little bit of accuracy in certain odd cases that maybe we haven't completely planned for. So that's the sort of stuff that I think is really cool. So anyway,
awesome.
This is fun.
Great. Yeah. And just to reiterate what David said, please, we want to hear what you all have to say. Let us know your thoughts. I mean, even if you like learned something, or maybe you're like, I don't know if this was like super helpful, or like please, we want to hear all the thoughts, all of them. So feel free to share with us in the chat, or if you don't love, you know, publicly being in the chat or whatever. Also our Slack, you can always like Slack either of us. So it doesn't have to be public if you don't want it to, totally fine. I'm definitely like, you know, totally understand. But regardless,
and also just like let us know if you want, like if we're going too sort of advanced or too deep or not deep enough or whatever else, like please do let us know, help us calibrate that. So yeah,
pretty much just, you know, you are our guinea pig. No, I'm just kidding. No, we want to create better content and what you all want to hear. So let us know. Awesome.
Cool.
Well, we will likely continue with more window functions to learn even more at some point. But we will have a schedule up hopefully soon for what we'll cover next week. But remember, we are officially on Thursdays at 2:30. So come join us again.
Which probably means we have like one more thing this year and then we'll be back.
That's true. That's true. Also, I just realized that we're the dentist time, 𝗔𝗶𝗱
𝗔𝗊𝘃.
All right, I'm gonna leave now because that was awful. So
thanks, folks. See you later.
Bye, everyone.